Dear students, today we are going to complete lessons 3, 4 and 5 in concept 2.1. Yesterday we started talking about the processes that the matter have such as freezing, melting, evaporation and condensation. Today we are going to talk about lesson 3 main activity, which say or tell us that the differences between the hot temperature and also the cold temperature. In this activity, if I have two beakers, one of them contains hot water and the other one contains cold water, then I will add some drops of the red dye in each beaker, and I will observe that the color will spread faster in which beaker, in hot water or in cold water. After a while, I observed that the color spread faster in the hot water, takes less time in hot water than in a cold water. Why? This is the reason. The conclusion here tells us that the hot water, because has more thermal energy, so it has more kinetic energy, so the molecules move very fast, so the color spread faster and takes short time in the hot water. While in the beaker that contains the cold water, the molecules here has less thermal energy, so they have less kinetic energy, so they move slower, and the red dye takes more time to spread through the cold water. So according to the temperature, the molecule started to move and the color started to spread more and more, faster, more and more. That's for lesson 3, just an activity, not more. What about lesson 4? Let's see. In this lesson, did an activity talks about the differences between the melting point, the boiling point, and also the thermal energy. What is the meaning of melting point? Melting point means it is the temperature at which the matter begins to change from a solid state into a liquid state. For example, if you have a piece of ice and an ice cube, and after a while it will melt, the temperature at which the ice started to melt into water, this is the meaning of melting point. So I can say that the melting point of water or ice is 0 degrees Celsius. What about the boiling point? Boiling points mean it is the temperature at which the matter begins to change from liquid state into gaseous state, of course by heating. So if I asked you, the boiling point of water is what? Is 100 degrees Celsius, which means that the water started to change into water vapor or steam at 100 degrees Celsius. What about the boiling point of mercury? Is 357. And when I'm talking about the melting point or the boiling point, I have to say the measuring unit, which is degrees Celsius, because the measuring unit of temperature is degree Celsius. The second part of lesson 4, this is the graph that shows you the differences between the melting point and also the boiling point. The second part that the lesson talks about what happens actually when you cool a matter or when you heat a matter. First, when you cool a matter, the spaces between its molecules decreases and they move slower and come close to each other, which means that they contract. This is the meaning of contraction property. But when you heat a substance, it started to change from a solid to liquid or even from a liquid to gas, and at this moment the spaces between its molecule increases, they started to move faster, so they expand. And this is the meaning of expansion. So at this part there is a big difference between contraction property and also expansion property. So thermometers, according to this property, we can depend on the contraction and expansion to make a thermometer. If I am going to make a model of the thermometer with alcohol inside it, if I don't have the mercury inside it, I can use alcohol. Then I can put the thermometer in a hot substance. At the first case, I will put the thermometer in the hot substance and its temperature will increase, its molecules, the spaces between its molecules increases, so they started to move faster and they expand, moving away around each other, moving away from each other, and the temperature give us a high level. which means that if I measure the length or the volume of the liquid inside the thermometer, it will be high. But if I made the opposite, in the other case, if I put the thermometer in a cold substance, of course its temperature will decrease, so the spaces between its molecules decreases and they come close to each other, which means contract, and when I measure the temperature, it will give me a low level of temperature. This is the differences between the contraction and expansion. I can apply the expansion and contraction in some activities in our daily life. If your mother in the kitchen is going to cook the food and wants to make a tomato sauce, but she cannot open the jar, the lid of the jar, and we know that the lid of the jar is made of metal. What will she do to open it easily? It will use a very simple way. It will pour a very boiling water on the lid of the jar. And because the lid is made of metals, and we know that the metals expand by heating and contract by cooling, so after pouring the boiling water or the hot water on the lid, the molecules, or actually the spaces between its molecules, increases and they move very fast, and at this moment it can open the jar easily. Also, we can apply expansion and contraction in another application, which is bridges, or actually the railway bars. We have to leave spaces between railway bars because railways are made of iron, and iron is one of the metals. In a high temperature it expands, and in a low temperature it contracts. So if there are no spaces between the railway bars, actually in the summer when the temperature increases, they expand it, and the accident will happen more and more. So to keep the bridges safe, we have to leave spaces between each bar, and also engineers can use expansion joint to separate between them to make the bridges or keep the bridges safe from buckling when they expand at a very high temperature. So today we talked about what? We talked about lesson 3, the hot water and the cold water, which one the red dye spreads faster or takes less time or shorter time to spread more and more. And also in lesson 4 we talked about the differences between melting point, boiling point, and the melting for the ice, the boiling for the water, and also for the mercury. The second part we talked about the differences between contraction and expansion, and how can we apply this property to make a model of the thermometer, or even to apply it in some activities in our daily life like the bridges or railway bars, and also for the lid of the jar. Let's answer some questions as we always do in the booklet. If I want to answer about contraction and expansion, if you have a question like this, complete the following sentences. Number 1, the increase in the volume of matter that occurs when heating this matter is called, of course, expansion. So when the volume of the liquid increases and giving a high level of temperature, it means that it expands. So this is the meaning of expansion as a noun. When we cool a matter, this is the opposite of number 1. When we cool a matter, the spaces between its molecules, excellent, decrease. But when we heat it, the spaces increase, right? Okay. What about number 3? By increasing the temperature of matter, its speed, the speed of its molecules, they move faster, which means that its speed increases, right? Right answer. And also its kinetic energy also increases. Okay. Number 4, when bridges are exposed to which weather? I don't know if I will write hot or cold, but the rest of the sentence tells me I will choose which word. Let's see. The spaces between the molecules of expansion joints. causing its expansion. Oh, and because the word expansion here is written, of course, when it is exposed to hot weather. So when bridges are exposed to hot weather, the spaces between its molecules or expansion joints increase, causing its expansion, increasing in its volume. Number 5, engineers use which joints to keep the bridges safe? We said before they use expansion joint, which already is written in the previous question. What about number 6, different materials, what by heating and what by cooling? Excellent. Expand by heating and contract by cooling. That's right. Thank you for your listening and wish you a happy day. Bye bye.